Greetings, everyone. We're halfway through the semester, and you might be facing a little bit of a struggle in Chapter 8, which is a chapter that's mostly theory, but it is the reason we can do all of the nifty things we do in statistics. So I just wanted to go over some notes I've had when I taught this in the classroom. The mean of the sample mean. That means if you have a lot of samples, and you take each x bar and you average them out, the mean of x bar is exactly equal to the mean of the population. Not close, not approximation, exact. In addition, the standard deviation of x bar, that distribution of the sample means you might get, is the population standard deviation divided by the square root of n. This is really good news, because let's look at a normal distribution here of IQ. It's got a mean of 100, standard deviation of 16, and it looks like this. Now let's say I take a large number of samples where each sample is size 4. You notice that the curve is still normal, but it is narrower. And what happens if I go up to size 16? I get narrower still. What that says is my x bar, my sample mean, is going to be somewhere clustered very close to the population mean. So that is why we can do so much good stuff here. But what happens if we don't have a normally distributed population? The central limit theorem. Oh, this thing is wonderful. So if you have a large sample size, the variable x bar is approximately normally distributed regardless of the distribution of the variable under consideration. So you can have something that looks nothing like a normal distribution for your population, and when you get your sample, by gosh, it's going to be part of a normally distributed sample set. So you are still able to use all of the normal methods that we've been learning so far. So good luck, and let me know if you have any questions.